Check 1, 2, check 1, 2. Lesson 105, Symmetry and Transformations. You're going to remember that in lesson 88 we talked about transformations, and we're actually going to flip back to lesson 88 during this video so that we can use an example with that F that we cut out on that grid to look at some lines of symmetry and transformations there. But the first thing is the definitions here. We have lines of symmetry. Okay, that's a line that you could divide a figure by that would make it look like a mirror image. And then we have reflective symmetry. Reflective symmetry is a figure that has reflective symmetry if it can be divided into two halves that are mirror images of each other. For example, like a heart has reflective symmetry because, like, for example, you could fold a piece of paper in half, cut out one half, and then unfold it, and it would look exactly the same, okay? So, like, that has reflective imagery, yeah? Because you could divide it right there without even doing anything, and this half looks just like that half, okay? Also with the circle or the letter D has reflective symmetry this way, a capital D, I should specify, not a lowercase d, obviously. Example 1. I am actually doing example 1 down here. Example 1 is down here, okay? Find the number of lines of symmetry in each figure. All right, the reason that I had to do it down here is because I realized I don't really have enough space and I did those too far up. So, I am human, please forgive me. It says here we show a regular triangle and a regular pentagon and a regular quadrilateral figure, the square, and a hexagon. And we're finding the lines of symmetry in each. Okay, so a triangle could be divided this way, and that could be a line of that is a line of symmetry because this half and this half look the same. Also, it could be a line of symmetry. See, so notice how this triangle I did actually measure, and it's right the whole way. So that means that from the top to the middle, that also means that if you turned it on its side, from this top to this middle right here, that's a line of symmetry. And then from this top, even though it's a side, if I turned it to this middle down here, that's a line of symmetry. So these are the lines of symmetry that you could divide into mirror images for a triangle. Now, for this pentagon, I have to admit, I am not that good at drawing pentagons. I don't know why they're so tricky, but for me they are. I'm going to show you the lines of symmetry that you're supposed to have if it was a perfect pentagon. If I was somebody who could draw a perfect pentagon, then these are the lines of symmetry you would have, okay? Mine might look a little different, and yours might too. I don't know. Maybe you are a person that can draw a perfect pentagon, and if you are, that's kind of a skill I envy. But anyways, all of these are supposed to be the equal distance, and I used a ruler even. I don't know what the problem is. But so this is a line of symmetry. That's pretty much the only one my figure has. But other perfect pentagons, it's supposed to be the same idea as the triangle, that you could go from every like corner and you could divide it to the edge of that, okay, edge of that, you know, the edge that's on the opposite side of that corner. And then the last one would be here. Okay, so those are the lines of symmetry. So it would go from one edge to the middle of that line that's across from it, and then one edge to the middle of that line that's across from it, and then one corner, the vertice where the two lines meet, to the middle of that one